One of my favorite things to do in Math 9 is to make random simulations using MATLAB or using Python. And to make a random simulation using Python, we need a way of getting some sort of randomness. And that's what I want to talk about in this video. So I've restarted the notebook, so need to make sure I import NumPy again. And then this should be a little shorter than the previous video. Here are the 4 things I want to do. So let's start out with this one. I want to make a length 10 NumPy array of random integers between 0 and 40. So let's see what I consider sort of the old way of doing this. You can say np.random.randint. And then I can say go from 0 up to 40. It'll automatically not include the 40. And then I can say size equals 10. And maybe I'll make this look a little better by adding spaces. So that worked fine. And say you wanted to look up the documentation for this, for example, because you wanted to know where did these 0 and 40 come from. So you can do help np.random.randint. And so here you can see 0 was low, 10 was high. And here you can see that exclusive part. So the 40 is never going to show up here. So 0 was low, 40 was high. I think I said 10 accidentally. And then size was 10. Okay, good. But if you go down here to this note, you'll see that new code should use the integers method of a default RNG instance. So let me show you how to do that. So I'd say so far, like as of summer 2022, you usually see this kind of way of getting random numbers in NumPy, but the NumPy documentation is telling us to use this other way. So that's what I'm going to do in Math 9. And that's what I want you to follow, is using this default RNG method. So let's see how to do that. And some parts of Python follow object-oriented programming, and this default RNG, I think, is a good example. So here I'm making an object that's going to produce the random numbers for us. It's a random number generator. That's what the RNG stands for. And the reason I think of this as an example of object-oriented programming is because in like my first way of thinking of how to do this would be, okay, you're going to have a function that outputs the array. Instead, what we have is an object, this RNG object. Oh, and I forgot the random. So I have this object, this random number generator object. If I look at the type, it's a NumPy generator. And instead of having a function like off on its own in NumPy to make these random arrays, instead I have an object, and that object has methods on it that can produce these random arrays. So this RNG, okay, if you come up here, it says use the integers method. Okay, so that's what we're going to do. We're going to say rng.integers, and then the syntax is the exact same. 0, 40, size equals 10. Okay, so that is the modern way of making random numbers, an array of random integers using NumPy. Okay, next, let's choose 6 of these numbers. So let's maybe save it. I'll save it as ARR. And let's just display ARR. And now I want to choose 6 of these with replacement, which means I could choose the same number twice. So how do I do that? Well, again, I'm going to use a method of this random number generator. So RNG, and the method is called choice. And then I want to say, where should I be taking the elements from? So they're going to be chosen from ARR. And then I'll say what the size should be. So size equals 6. And here you can see it chose this 30. It chose it 3 times. So you can really see them with replacement in this case. Okay. Next, let's make a 3-row, 5-column NumPy array of random real numbers between -1 and 4. And so what I would have expected would be, well, you need to know what the method is called. It's called random. And what I would have expected would be, it would be something like -1, 4, size equals, okay, and then I'll give it a tuple, 3 by 5. Okay, but unfortunately, this does not work. And so let's check the documentation for this random method. And so you see the very first argument to this random method is supposed to be size, and it's always returning real numbers between 0 and 1. So how do we get it between -1 and 4? Well, we have to artificially get it into the correct range. So this, let's do the RNG random on its own. So there's 3 by 5, and this is always between 0 and 1. And maybe I'll save this. I'll call it ARR again. So here's what ARR looks like. And then I can subtract 1 from it. Or no, let me first multiply. ARR times 5. And where did 5 come from? Well, these numbers span a range of width 1, goes from 0 to 1, and I want the numbers to go from -1 to 4, so I wanted to go from a width of 1 to a width of 5, so I'm achieving that by multiplying by 5. And so now they go from 0 up to 5. Okay, here you can see something that's between 4 and 5. But I wanted to go from -1 to 4. So I can do ARR times 5 and then -1. Okay, if this makes you nervous, you can always put this highlighted part inside of parentheses, but you can be pretty confident that multiplication will happen before the subtraction. Okay, so now this goes between -1 and 4. And in general, it won't be written this way. It'll be written sort of all at once. So we can do 5 times RNG.random. Okay, size equals 3 by 5. Okay, or you can leave the size equals portion out. That's fine. And then subtract 1. So the 5 times, that got us the correct width. And then the -1, that got us into the correct range. Okay. Here's the last one. I don't know how much we're going to use normally distributed random numbers, but just want to show you that it works basically the same. And you can probably guess what the method is called for getting normally distributed random numbers. It's called normal. So let's check out what the documentation says. Or not .random, I want .normal. And so I don't know why they call it loc and scale. But if we check, loc is the mean, scale is the standard deviation. And what size did I want? I wanted length 10. So I can do RNG.normal. And I can't remember, what did I want for my mean and standard deviation? I want mean 2, standard deviation 0.1. So we should imagine these are going to be clustered pretty close around 2. So mean 2, standard deviation 0.1, and size equals 10. Okay, it sort of looks like it's 2 by 5, but notice there's no bracket here. This is length 10. Okay, if I were to check what's the shape of this, you get that it's length 10. Okay, so just a one-dimensional NumPy array. So that was a quick introduction to some of the different methods we can use related to randomness in NumPy. We saw the integers method. We saw the choice method for choosing random elements from pretty much anything, but in our case, we chose it from an array. We saw the .random method for getting random real numbers between 0 and 1. And here we saw the normal method for getting normally distributed random numbers. And you can just notice that it does seem to be clustered around 2. Okay, remember this was mean 2, standard deviation 0.1.